Hey there. Ever wonder what makes an app or a game feel, well, smart? It all comes down to two basic things: making decisions and repeating actions. That's it. And today, we're going to break down exactly how code pulls that off. So let's start with something super simple, something we all get. How do you figure out if a student passes or fails? You don't even have to think about it, right? You just check their score. Well, that simple act of checking, in programming, that's called a condition. Think of conditions as the basic rules that a program follows. It's the if this, then that thinking that's running behind the scenes of pretty much everything you use on your phone and computer. Okay, so let's get into our first big topic: code that decides. This is where we're basically going to give our program a brain and teach it how to evaluate a situation and then pick what to do next. The simplest decision in all of coding is like a fork in the road. It's called an if-else statement, and it's exactly what it sounds like. If something is true, you go down one path. Otherwise, you go down the other. Simple as that. And here's what that looks like in the wild. We've got a variable called marks, and we set it to 40. The code then asks a question: is marks greater than or equal to 35? Well, 40 is, so yep. It runs the code in those first squiggly brackets and prints out pass. Now, if the marks were, say, 30, it would just skip that part entirely and jump right to the else block. Let's just quickly tear that apart so it's not so intimidating. The if keyword is what kicks the whole thing off. It's the check. The actual question, marks is greater than 35, that's the condition, and it always lives inside parentheses. The curly braces, they hold the action, what to do if the condition is true. And of course, else is just the backup plan. So you might be wondering, how does the computer actually understand what greater than or equal to means? It doesn't read English, right? It needs special tools to compare things, and those tools are called operators. And here they are, the basic toolkit. You've got your usual suspects, greater than and less than. But check out the equal signs, because this is super important. A double equals, is kind of relaxed. It just checks if the values are the same. So to it, the number 7 and the text 7 are the same thing. But the triple equals, oh, that's like a strict bouncer at a club. It checks that the value and the data type are a perfect match. Now, what if you need to check a couple of things at once? Like, is a person's age between 18 and 60? For that, we use logical operators. The two ampersands and mean and. Both things have to be true. The two vertical bars, / mean or. You just need one of them to be true. So we've handled a simple pass or fail, but what about a real grading system? You know, A, B, C, D. When you have more than just two possible outcomes, you can just chain these checks together using if, else. Let's follow the computer's thinking here. The score is 82. First, it asks, is 82 greater than or equal to 90? Nope, so it just moves on to the next else if. Okay, is 82 greater than or equal to 75? Yes, ding, ding, ding. It runs that code, prints grade B, and this is the really important part, it stops checking. It found its answer and it's done. All right, we've given our code the power to decide. Now for the second superpower, teaching our code how to repeat itself. This is how we get computers to do all the boring, repetitive work for us. We do this with something called a loop. And a loop is really simple. It's just a way to run the same chunk of code over and over and over again as long as a certain condition is true. So instead of copying and pasting the same line 100 times, you just write it once inside a loop. The most common type of loop, the one you'll see everywhere, is the for loop. This is your absolute workhorse. You use a for loop when you know exactly how many times you need to do something, like count from 1 to 10, or process the first 50 emails in your inbox. Okay, this line might look a little crazy, but it's actually pretty simple when you break it down. It has 3 parts. First, let I equals 1 sets up a counter for us. Second, I less than or equal to 5 is the rule. The loop will keep running as long as our counter is less than or equal to 5. And third, I plus plus just adds 1 to our counter after every single pass. The result? It prints 1, then 2, then 3, 4, and 5. But what if you have no idea how many times you need to repeat? Think about a game waiting for you to press the start button. It just has to keep waiting and waiting. For that, we use a while loop. It's like a lookout. It just keeps running as long as its condition is true, whether that takes a millisecond or 10 minutes. Now, the while loop has a slightly different cousin called the do-while loop, and this is a really key difference. A regular while loop checks the condition before it does anything. So if the condition is false from the start, the code inside never runs. But a do-while loop? It runs the code once, no matter what, and then it checks the condition. This guarantees it always runs at least one time. Okay, so you've got the basics of deciding and repeating down. Let's get into some pro tips now so you can really take charge of your code and, more importantly, avoid some really common headaches. Sometimes you need to jump in and mess with a loop while it's running. You've got two main tools for that. Break is basically the emergency stop button. It kills the loop instantly right where it is. Continue is a little different. It's more like hitting skip on a song. It just ends the current cycle and jumps straight to the top for the next one. All right, let's talk traps. These are the things that get everyone at some point. Using a single equals sign when you meant to use 2 or 3, that doesn't compare things, it changes the value, which can cause some really weird bugs. And the big one, if you forget to update your counter in a while loop, you create an infinite loop. Your program will just get stuck running forever and completely freeze up. So why are we spending all this time on if statements and loops? Because this stuff isn't just for a test. This is the fundamental logic that makes our digital world tick. That if-else check, that's what a self-driving car uses to decide whether to hit the brakes. That for loop, that's what renders every single frame in a video game 60 times a second. Understanding this is understanding how modern technology works. And speaking of why this matters, let's do a quick pop quiz with a question you are almost guaranteed to get in a tech interview. So what is the difference between a double equals and a triple equals? And here's your answer, plain and simple. Double equals, only cares about the value. Triple equals is much stricter. It checks that both the value and the data type are identical. And here's a pro tip for you. Just get into the habit of always using triple equals. It's safer, it's clearer, and it'll save you from some really strange bugs down the road. So that brings us to the end. We've looked at the tools for making decisions and the tools for repeating actions. So I'll leave you with a challenge to chew on. Now that you know how to do this, how would you put it all together to build a simple calculator? Something that can add, subtract, multiply, and divide. Think about it.